So the first few weeks are going to be spent doing a little bit of a review, which I think is okay with a lot of people. So we're going to go to Chapter 6, Object-Oriented Programming, because I assume at this point we all pretty much know how to do procedural programming. Procedural programming meaning you have A is equal to A plus 1 followed by, print A, that kind of stuff where things happen in a row. And we probably also have the idea of functions. Whoopsie, stop that. Which we call modules. Excuse me, which we call methods in this language. Modules if you're taking fundamentals of programming. Can we get it darker up here, please? Okay, fine. Can we turn the light off? Can I put my fingers on the right buttons and we'll have more success? Yeah, there we go. All right, so what is an object? It's a collection of data. And they use this silly term, it's got a set of behaviors. Right. Well, a pig is an object. It's a collection of data. What is that data? It's all the position of the atoms and everything in it, right? It's a bunch of atoms hooked up together to form a pig. And the way the atoms are hooked up is the information. And it's got some so-called behaviors. What can you do with a pig? Right? You can throw it in the pig pen. You can eat it. Right? You have several different behaviors that you can. Those are methods. Methods are the functions that can act upon and use the data of the object. So, you could have an employee object. You could have a customer object. You could have a student object, right? Every student has, a birth date and a, birth state or address, all that kind of information. Time. Time is actually more complex to manage than you would think. So the objects that control time are actually fairly sophisticated. Not control time, but you know what I mean. Complex numbers. Complex numbers are something with both a real component and a so-called imaginary component. Points in a coordinate system, like an X and a Y, or an X, Y, and a Z. Those are all the data that they can hold, and no mention of the so-called behaviors yet, right? But what might you want to do with an employee? You might want to set their hire date. You might want to, give them a raise or assign them to a new division. All of those verbs are the methods that you would create for the employee class. Just like for a math coordinate class, you might want, a set position method that would set its X, Y, and Z value. Or you might want a method that would measure the distance between 2 points. So the rest of the program is using the object, and the object has some data inside it, and normally you don't expose the data directly to the rest of the program. So you make your data private and your methods public. And those of y'all who took Intro to Java with me got real tired of me saying this, but the rules, the guidelines for creating classes. One, data private, methods public. What are methods? They're just the functions that are attached to the class. Two, add getters and setters for the data. Good enough. There's going to be more, but those are our starting guidelines for classes. What is a class anyways? Well, we said it an object. I don't even think we defined it. If we said an object was a collection of data and behaviors, the class is the template for that object. So let's say a class is a template or blueprint for an object that is a collection of data and the methods that use that data. Use it, change it, whatever. A little bit different than their definition, but I like it. And an object is an instance of a class. So you might have a class called pig, but you have an object named Porky. Or what was the pig in Charlotte's Web name? Wilbur, something like that. And another object named Wilbur, and you might have two cats, right? You have a class called cat, and you have Felix and Sylvester as objects of that type. So if we did that coordinate idea, what kind of information does a coordinate have? Got an x position and a y position. And if we're doing three-dimensional space, it'd have a z position. And if you're doing physics, you can have a vector which has both a coordinate and a direction of force. We're not going to mess with that. We're just going to stick with what a coordinate is. It's got an x position and a y position. So those are pieces of data. And then, so let's divvy this up. I'm just going to draw a little line here, and I'm going to say that that's the name of the class up here between those dotted lines. And then I have that stuff there. And then here I have some methods, right? I might want to be able to set the position. I might want to be able to get the position of x. I might want to be able to set the position of y. And I might want to be able to get the position of y. This is halfway towards creating what is known as a UML diagram. In a UML diagram, the first block is simply the name of the class. The second one is the data. And the third block are the methods that use that data. And here's what I'm going to do next. I'm going to try to turn these into a little bit better than just these vague English descriptions. We're going to say that x is a double. In other words, it's a floating point variable with double precision. We're also going to say that y is a double. It's a floating point variable. And we're going to put minus signs in front of them to indicate that they're private. But let's not make them private yet. As a matter of fact, we're not going to make them private yet. And so set x, a setter doesn't need to return anything, right? Because you're telling it what to do, right? You tell your dog to go over there, he's supposed to go over there. He's not bringing anything back. So he's going to return nothing. So we put colon void there. Same for set y. He returns nothing, so we're going to put void there. Now get x is supposed to get the position. When we tell our dog to get something, he's supposed to come back, bring us something. So he's got to return something. Well, if x is a double, he needs to return a double. And get y is the same way. Since y is a double, he's supposed to return a double. This is much closer to a UML. Only thing missing is that setters require data to be passed in, right? Require a double to be passed in, while getters don't require any data at all, right? Because I'm getting the value. I'm not doing anything with it, I'm getting it. So the setter needs to take a double value to specify what we're setting it to, right? We need to know that we're going to set x equal to 0, so we have to pass a value in. Whereas the getter, we're asking it for the value, so we don't pass anything in. And we may as well give parameter names while we're here. So I'm going to say that the parameter name is going to be called x, and it's of type double. And the parameter name here is going to be of y, and it's of type double. Now normally I just create the UML already in this format rather than create it in one format and then keep making little changes to it. Usually I just start off the top of my head already knowing what it's going to look like. So this middle part is the data. Our data is pretty simple. It's only got an x and a y. And then we have 4 methods to manipulate the data. So when we create our class, I could type it in here and then type it in again under NetBeans, but why don't we just type it into NetBeans? So let's make a lecture B. File, new project, lecture B. Put your name up at the top of it. Right? Not my name. Hey, you lost. This is lecture B, although we can obviously tell that we're in chapter 6, classes and objects. There, cleaned up a whole bunch of stuff. Now, we had 2 pieces of data as part of our class, but I'm not going to add them to this class. Why not? Because the class was supposed to be called coordinate. Well, why didn't we call this class coordinate? No, we don't call ourselves, we don't call ourselves the pig. We use a pig. We're the outside force that's going to use the pig. What we need to do is declare a class outside the driver class. This is the driver class. This is like the main function of a Python or a C program. In fact, it's called main right here to indicate. So this is the main class. We're going to make a class that the main class uses. And here's how I want it to look. And by the way, I know that I'm misspelling coordinate, but I'm afraid that there actually is already a class named coordinate, so I'm just going to call it chord. Bear with me. So, I want to be able to do something like this. Chord C1 equals new chord. I want to be able to create a new chord object, but I don't have a chord class, so it's underlining that, right? All over the place. When I add my chord class, those underlines will go away. Now what you should do, that should be another guideline, is every class in its own file. That ought to be like rule 0, right? Every class in its own file, and the file name has to match the name of the class. Are we going to do it that way? Are we going to be rigorous enough to do it that way? Yeah, why not? Let's pretend that we do good programming practices in here. So I'm going to go over to projects. I'm going to close lecture 8. Well, at least minimize it. You see where lecture B is? Find lecture B here. And right-click near it, above it, on that folder that says lecture B. It's actually the package. And do new Java class. And let's call it chord. And here we go. It says public class chord. I'm wondering if I can get them to kind of divide up like that. I don't know if I hate this or not. Let's find out. All right, so we had 2 variables, x and y, and we made them doubles. Double x, double y. Now I'm going to save this file, this class. I'm going to hit Control S, and these errors should go away. I said these errors should go away. Why have they not gone away? There, finally. All right. If I built it, it probably would have worked. If I'd hammered and broomed it. All right. So, since these are not made private, we can access them directly from here. Soon enough, you're not going to be able to once we do make them private. But c1.x equals 7, right? And c1.y equals 20. That works, right? And then we can make a second point that had different x and y values. Chord C2 equals new chord, parentheses in parentheses, semicolon. C2.x equals 0. C2.y equals 1. And I accidentally typed a comma rather than a semicolon there. Just for funsies, I guess maybe let's add a method that we didn't have in our UML. Maybe we'll go back and modify our specs. A print method that prints out what it is. I'm a point and my x value is this and my y value is that. So print. Doesn't need to return anything, so it's void. Let's do that. Let's add a print method to our class. Void print, parentheses in parentheses. No semicolon there, even though I started to type it several times. And then an open curly brace and a closed curly brace. Let's see how that compares to that so far. I'm going to pull up both of these and we can look at them. You see the similarity. I guess I could change the name of this to match that, right? And yes, I still recognize that it's wrong. I'm not sure why I wanted to name it differently. X colon double, well, that's just a UML, and UML applies for any languages. It's not a syntax that Java would recognize, so we had to put it in the correct syntax, where we list our variables in the correct syntax, which is to type followed by the name in the semicolon, and then to type followed by name. Same for methods, right? That's not the syntax for declaring a method in Java. This is the correct syntax. Let's make it say something. System.out, here I better close that up. System.out.println parentheses. Maybe we ought to make it a printf. Printf, so that we can do these placeholders that I'm about to do. I'm a coordinate. My x position equals %f, comma, my y position equals %f, end parentheses, end quote. Come on. And then after the quote, we need a comma, and we need to list the values that are going to fill in these placeholders. So this dot x, comma, this dot y, in parentheses, semicolon. And if I don't put a backslash in here, then when it prints, it's not going to go to the next line. So before that closing quote, I believe I'll put a backslash in. Bless you. Alrighty. Let's add a call to the print method to our lecture file. I really do not need lecture A. So let's print out our 2 points. Chord, no, not chord, because that's the name of the class, not the object. C1 dot print, parentheses in parentheses, semicolon. C2 dot print, parentheses in parentheses, semicolon. So I hammer and broom it to build it. I don't think I got any syntax errors. How could I tell? Well, if I do window output, there's my output, build successful. Let's run it. Green arrow it. Yep, and it printed out my 2 coordinates. One with a value of 7, 20, and the other with 0 and 1. Now I haven't added the getters and the setters yet, which is what we should do. It's kind of a rule of thumb that you should add a getter and a setter for each variable, unless there's no reason to let the user, the programmer who's using your class change the data. NetBeans gives you a really quick way of adding getters and setters, but we're not going to do the quick way yet. We're going to do it the boring way, which is to add them by hand. So the reason that I would need to add getters and setters is if these were made private. Private means that nothing outside of the class can touch them. So private space and private space. So now I just broke my code. If I go back and I look at my lecture code, now these are marked with errors because they're private. I can't set them anymore. I can't access them anymore. That's why I'm going to provide what are known as mutators and accessors. Accessors are getters and mutators are setters. I'd rather say getter and setter because they're English, not Latin terms. But all right, so what does a getter do? It needs to be of the same type as the variable. Double get capital X, parentheses in parentheses, open curly brace, return this dot x semicolon. And while we're on a roll, let's go ahead and do the getter for y at the same time. And then we'll do the setter for x and the setter for y. Double set x, parentheses in parentheses, curly brace. Wait, I said I was going to do a getter. Double get y, capital Y, parentheses. Return this dot y. I could have just copied and pasted it and changed, some x's to y's. All right, that still didn't fix the error. We're going to have to come over here and change this, but we haven't written the method yet that will support the change because we need setters. We're trying to set x to 7 and y to 20, so we need to add 2 setters to support that. But they don't need to return anything. And I could keep going over here to refer to this, right? But I'm just going to do it from my memory. The setter takes a variable and doesn't return anything. It takes a parameter variable. So void set capital X, parentheses, double x. I'm adding more spaces than you need to. Why is it a double? Because if x is a double, we want to pass in a double to set it. In parentheses, not semicolon, curly brace, this dot x equals x. And this dot x refers to the member variable, and this x refers to the parameter value being passed in. And now if you just copy these 4 lines of code, or 5 lines of code, whatever they are, 4 lines of code, and change the x's to y's, then we'll have taken care of the setter as well. So instead of that, that's going to be set capital Y, double Y, this dot Y equals Y. So one could argue that we've unnecessarily fluffed up our code by about 400% by making the data private and then adding all these methods as getters and setters. But this is the correct way of doing it, is to protect our data. In this particular case, the data didn't really need to be protected. What do I mean by protected? The goal is to make sure that the data is always in a good state. And so, for example, what if a point can't have a negative x value? Then you would make your setter check to see if it was trying to set a negative value, and if it wasn't, it would forbid it. Right? So this setter could be a gatekeeper for those values, maintain good data states, not allow the calling code to ever change it to inaccurate states. But we're not doing any checks. Anyways, we're going to follow good programming practices most of the time. So now that I've got this code, I can use it over here. So instead of c1.x equals 7, c1.set x, parentheses 7. And the same for c1.y. Change that to c1.set y, parentheses 20. c1.set y, parentheses 20. And then fix these 2 calls as well. So that's an x and a y, right? So this needs to be c2.setx, 0, and c2.sety. Whoopsie, didn't mean to hit that key. c2.sety, parentheses 1. Excuse me for my mistypes. This instructor computer has a somewhat strange keyboard. Now when I run it, we should get the same output that we did before. And I did. It printed them out again. couple more things I want to do just to tidy things up is we made these pieces of data private, so we're going to go and put minus signs in front of our UML for those. Minus just means private. And a plus sign means public. In this language, unlike C++, the default is something very close to public. So that's why it worked even though I didn't put public in front of all of these. But the guideline is data private, methods public, so I'm going to add the little plus signs to all of these. And then I'm going to go and add the public keyword to all 5 of my methods as well to make them match. And then we'll say we have a good class, and we'll go back and hit the PowerPoint. So coming back over here to modify my class to match, all the methods are going to be marked as public. I may just copy and paste it, right? Type it once, paste it. All right, so an object is a collection of data and the methods that use that data. Can you have an object without any data? Yeah, sure. Could you have an object without any methods? Sure. In C and C++, it's called a structure. Just don't attach any methods to it. But usually, it's a collection of data and the methods that act on it. And a class is a blueprint for that object, leading us back to the definition of a class as being a template or a blueprint for an object that is a collection of data and the methods that use that data. Oh, I didn't pause and check to make sure everybody was doing okay. Let me do that. So the class is, oh, we got to use another word, description. I'm going to leave it with blueprint. They're saying, for example, you have 3 different computers, and each computer has some information associated with it. They don't seem to specify what, but like the color of the case, the number of hard drives in it, the size of the hard drives, you know, and the price, something like that. Those might be the specifications of the computer. Those might be 4 pieces of data you want to track for them. So your class for computer might have a hard disk size, and it might have some others. And computer class could also have something called print specifications. So after you create a computer object, you could print it out. Might print out all of its information, including the hard disk size, the CPU speed, and the cost. We could go and make a class for computer that has a hard disk size, CPU speed, and cost. Let's do that. Even though we're not going to fill it in with getters and setters, we don't need to belabor that point. Let's go back here, go to projects, right click on our package folder, and do new folder, and make one called computer. Where'd it go? Did I not do it? New. Oh, why did I create a folder called computer when I actually want it to be a class? New Java class. You probably did it right while I was doing it wrong. Computer. All right. So this is going to have 3. Hard disk size, CPU. Is that what they showed there? Speed. And cost. Let's add 3 methods. Excuse me, 3 member variables. The book starts getting fancy and calling them instance variables because they can change. Each computer can have a different cost. So every instance of a computer can have a cost, a different cost associated with it. All right, hard disk size, why don't we make it an integer because you can't have, well, I guess you could, 2.5 megabytes, but people don't usually think like that. Right, so int. The largest a int can hold, if anybody remembers from other languages, is about 2.2 billion. Why don't we just say that this is going to be gigabytes, right? Because nowadays people measure things in terabytes. So let's just say hard disk GB for gigabytes, right? Otherwise, I was going to have to make it long, right, so that it could hold numbers larger than 2.2 billion, because it's very rare to find a computer that has less than 2 gigabytes. All right, CPU speed. CPU GHz, gigahertz. But you can have fractional gigahertzes, right? Like 2.6. My Intel has 2.6. So I'm not going to make that an int. I'm going to make that a double. And tell you what, why don't we just make all the numbers doubles? And then lastly, cost. Since we like dollars and cents, we're going to make that double as well. If we made it an int, you couldn't charge them cents. Always got to tack on that .99. All right, we've made a class called computer. We should go and add getters and setters for it. We're going to do it the cheap, fast way now, which is to let NetBeans do it. That's why we went to the trouble of installing NetBeans. We're going to highlight those 3 variables. We're going to come up here and do refactor, encapsulate fields, and we're going to let it add getters and setters for each variable. And it does it, and it makes it real ugly with a whole bunch of extra comments, but that's fine. The only change I'm going to make after it does all that is I'm going to cut the variables and move them back up to the top of the class, because I don't like the fact that it pushes them down to the bottom. I'll repeat that step though. Then I'll do that. Okay, so all I did is I highlighted those 3 variables. I chose refactor, encapsulate. Make sure they're all checked, which they are. Click refactor. And I don't like the fact that this stuff got pushed down to the bottom of the class. So I'm going to cut them, paste them, and move it up to the top after the first curly bracket. And if I was going to take the time to make it really pretty, I'd go and I'd remove all these comments. And that one. Right. I don't see much need to actually use this. But why not make a computer? We've already used C1 and C2, so how about CO1 equals new computer, parentheses in parentheses, and CO1 dot cost. We don't have a get, yeah, get cost. Let's set the cost first. You can't get the cost until you've set it, right? So set cost. This is an expensive computer. It costs $9,999. CO1 dot set CPU gigahertz. This is a 3.9 gigahertz. And CO1 dot set hard disk in gigabytes. He has a 4 terabyte drive, so that's 4,000 gigabytes. We haven't added a print method. We're not going to do anything else than just that. So what's really happening when we click build is it's creating what's called a bytecode file. And then when that bytecode file is actually executed by the Java runtime engine, the Java virtual machine, when you see a statement like this, it goes out and allocates a little bit of memory and stores the address of the memory in that variable. And then this memory here is going to have these 3 pieces of information in it. So the next time we create a new object, it goes and allocates more memory. Since a double is 8 bytes long, then this object is going to be about 24 bytes worth of data. So it's going to go and grab another 24 bytes of data and copy the address of that into there. So if you did something silly like this, chord C3 equals C2 semicolon, you haven't actually copied the object. You've just copied the address. right? It's like me photocopying my address. Now I have two addresses, right? Pointing to the same house. So this is not a way of copying an object. We would have to do something else to get that object to be able to be copied, but that's a point for another lecture. So C1, C2, and C3 are so-called reference variables. And another name for a class is reference type. Why is it called a reference variable? Because it refers to some memory, right? This allocated some memory. So this is a reference to that memory. It's a reference to that object, or to the memory that contains that object, if we want to be as precise as possible. And if this is going to be a reference, then I guess we have to call that a reference type. I like the word class better. Why do I like the word class better? Because that's the word that we actually use in order to create it. Things like int x and double y and boolean b and char ch, those are all primitive types. They're primitive because they don't hold an address to an object. Instead, they actually hold a piece of data. X equals 3, x holds the value 3. It doesn't hold the address of 3, it holds the value of 3. Y is equal to 4.4, it contains the value of 4.4. B is equal to true, then B gets a value probably of 1. Probably treats zeros as falses and ones as true. And character, let's give character a value like of an X, but we got to put single quotes around it. Unlike Python, it's very specific. You have to use single quotes if it's a character. So these are all primitive types, and notice the lowercase letters. General rule: primitive types begin with the lowercase letter. Reference types, parentheses classes, begin with an uppercase. Now you can make your own classes, right? And so you could make them with lowercase letters. But if you do, Santa Claus isn't going to give you any presents. So make sure that you give them all uppercase letters. It's just a rule of thumb that pretty much everybody agrees on. All classes should begin with an uppercase letter. So what about string? If I do string name equals double quote Bob in double quote semicolon, is that a reference type or a primitive? Take a guess just based on the fact that what is its first letter, uppercase or lowercase? It's uppercase, so that means it's a reference type, just following their rules. C++ doesn't follow the same rules, and so you call it a lowercase s even though it's a reference type. In C#, everything is a reference type, even things like ints and doubles and booleans and chars. But in Java, these are all primitive data types, meaning that they just contain a couple of bytes of data. Each one, like an int holds 4 bytes, a double holds 8 bytes. I didn't even throw a long up there, but that's all right. Okay, so string is a reference type, meaning it's got methods attached to it, just like any other object. These are primitive types, so they're not objects, so there's no methods to it. I can't type x dot and get a list of methods for the x variable. It doesn't have any, it's a primitive. But if I did name dot, then NetBeans would pop up a whole bunch of methods, right? If I wanted to get the lowercase version of Bob or the uppercase version, or if I wanted to see if it matches something, or check to see if it's empty or something like that, right? It's got all sorts of methods. that's part of the string class. And if this was configured correctly, I could come up here and hit string and choose right-click show Java doc, and it would show me all the documentation for it. And lo and behold, I think it's going to work. In our last classroom, it wasn't working. Cool. And so you can read all about it. So these things here, computer size or hard disk size, CPU, and cost are what are known as instance variables. Because each computer can have a different hard disk size and a different CPU and a different cost. Each instance of the class, in other words, each object, can have different values for those variables. And we saw that, right? We created two different points so they'd had different x and y values. There's another type of variable as well as instance variables. Those are called class variables. A class variable applies to the class as a whole, so every computer would have the same value for that variable. Now, I'm not going to even bother creating a class variable, but if I wanted to, I would use the word static. I would put the word static in front of one of these, and that would turn it into a class variable, meaning that every computer we created had the same hard disk size. Well, you know, maybe brand would be a good one to make static. Every computer we make is of the same brand, so why not? Static string with a capital S brand. If we change the brand for one computer, it would change it for all. Static is a class variable, so the variable applies to all objects of that class. Every class shares the same brand because of that static keyword. Every time you see the word static, just think class. Every time you hear me say class variable, think static. Why didn't they make them the same? I don't know. I guess because the word class is already used up here, and so it'd be kind of confusing if you put class there as well. Where did our computer go, though? Over down here, after we set the hard disk size and all that, let's set the brand. Right? CO1.brand equals, quote, Dell. It's going to give us not quite an error, but it's going to give us a warning. And I'm going to go and click on the warning and find out what it says. And what it's going to want me to do is to change CO1 to the name of the class, which is computer, because it's a class variable. Brand does not apply to any specific computer. They all have the same brand name. So computer.brand equals Dell, because it's a class variable. So it should be referred to by its class name rather than an instance name. Now it gives you a warning, but it would compile if you got it wrong. It'd go ahead and compile. It's not really a syntax error, but it's kind of confusing, because if I type CO1.brand, it makes it look like I could then type CO2.brand and set it to something else. But if you did that, then suddenly CO1's brand is also Dell, or whatever you changed it to, right? So our UML stands for Unified Modeling Language. And it's much more complex than what this shows here, because if we Google up UML diagram example and we click, we can see that they get very complex. They can show the relationship between classes. But what we're going to do is we're just going to talk about what's in the class. And yes, UML diagrams can show what's in the class as well, right? Here's something called reserve, and it's got 4 pieces of data and 1 method. Here our mouse has 3 pieces of data and 3 methods: set, percent, grow, and display. Normally I walk us through creating this on our own, even though the source code for it's already here. Normally I add that. And let's not do that this time. We might do that on Tuesday. Okay, so private and public. If something is private, you can't access it over in the driver. Right? This is the driver class. It is the client for the coordinate class and the computer class, or it drives them. I really don't like that term. I'd rather say this is the client code, right? But it uses these classes. So the driver code uses the client code. And it's so easy to get in a habit, like if I say, okay, I want you to make a project that involves a sphere class. And so you call your project sphere, and you make your driver code sphere, and then you kind of get stuck because you start trying to add data to it. But no, that's your driver class. The main method should always be separate from the data classes. So you shouldn't have a main method inside your sphere class. You should call put that main method in a different class. But if I made brand private, this is no longer going to work. So I better not make it private. Or if I make it private, I'd have to add again in a setter for it. Now that it's private, the client code cannot change it. I guess it's not going to show it as an error until I try to build it. Yeah. Well, so I'm going to make it public. Violate my rule about data private, methods public. So if you declare a member to be public, then the member can be accessed from anywhere. One thing about that static keyword is if something is static, if a method is static, it can only access other static members of the same class. So since the main method is always declared as static, that means any other methods that I added to the lecture class would also have to be static. And public static void test, parentheses in parentheses, right? And I don't even know what it's going to do. Oh, I've messed up. I lost a curly brace and everything's indented wrong and everything there. I'm going to try to fix it up. So all this is going to do is print a message. System.out.println testing. Right. If this was not declared static, if I deleted that static keyword, which I don't want you to do because it's going to break it, then I would not be able to call test, because he's in a static context. When you're in a static context, you cannot call access non-static members of the same class. So I'm going to go ahead and add the word static here again. Now public methods and private methods can call each other, right? No problem, as long as they're inside the same class. But private means only accessible inside that class, and public means accessible to the client code as well. So I'm going to add a comment to that effect. Public members can be accessed by the client code. Private members can only be accessed by code within the class itself. So get cost and set cost can access that variable. However, over here in main, if we said co1.cost equals 7, that would fail because it's marked as private. Instead, we have to say co1.setCost, because setCost is a public member, and so are the getters. So make your getters and your setters public and your data private, and you're good to go. So the static keyword is used to denote class members, like class variables. But you can also have static methods, class variables and class methods. Leave the word static off to make instance variables and methods. So the driver class for the mouse, they made a mouse object, and so the driver is the one with main, and then main creates a couple new mouses, creates a couple of new mice, creates a couple of new mouse objects. That's the correct way to say it. Anytime you're creating an object, you have to follow this syntax: reference type, variable name equals new reference type, and then put some parentheses in, and if it requires any data inside those parentheses, you put it in there as a parameter variable. So to declare a reference variable, you have to give it the class name and then the reference variable, like we had cord C1, computer CO1. And then to instantiate it, create an instance of, then you use that variable name equals new class name followed by the parentheses. So there we're declaring a mouse, and here we're instantiating the mouse. So let's kind of stop here and let's make a itchy-bitchy little homework assignment involving these concepts. Create a class that has variables to hold information about, or create a book class. A book class that has variables to hold information about books. Add at least 4 variables to it, 4 instance variables. You get to pick them, right? Like pages, publisher, author name, whatever, right? Don't bother make the variables public. Use the class. Yeah, I'm not going to even say use the class. Yeah. We got to prove that it works, right? And then have the main method of your driver class create a book and assign those 4 variables. And then secondly, create a rectangle class that has 2 variables, height and width. They should be private and double. So you need to add getters and setters for them. And then have the main method of your driver class create a rectangle and assign the height, or set, because we're using setters, right? And set the height and width using the setters. Reminder that setter the book calls mutator, and getter the book calls accessor. Alrighty, so we'll make this do on on Sunday of the following week, which is really way too much time. But if I said that I'm going to make things due for 9 days for the online students, then that would make it due Saturday, which is silly. So we're going to make it due Sunday night. Please get it done before then. As soon as you get NetBeans done, start working on your homework.